So I'm going to be talking about climate change in Nova Scotia and essentially the empirical evidence behind temperature change. And I'm going to be looking at both impacts in the terrestrial environment in terms of plant phenology and in the marine environment with respect to a particular seaweed that we've been studying. Next. So much of this work on temperature change has been done with Nick Hill, and the remainder of those are people that have been collaborating with me on the seaweed part of this work. Next. So the two major themes are essentially empirical evidence on climate change in Nova Scotia, and this is based primarily on annual temperatures at major sites around the province and how these have changed. And then we're going to look at how this has been manifested in the marine environment with a case study on this invasive seaweed, Fucus Serratus. Next. Okay, so when we look at temperature change, we can look at it from a variety of perspectives. And the data that I have in hand looks at essentially all of these metrics, numbers of frost days in the spring and fall, days to the last frost, days to the first frost, and number of continuous days without frost between spring and fall. So I'm not really going to be talking about those metrics per se, but all of that forms a background to what I regard as some of the key implications of annual temperature changes and monthly mean changes. Next. Okay, so what kind of changes have we specifically seen and been looking at from at least the botanical world? These changes, and we published on flowering phenology. In 2001, we had a very late fall, and we recorded 96 species of flowering plants in flower, and that ended December 20th. And then in another very warm fall and early winter, we recorded 135 species in flower. And those very dramatic changes are recently becoming more expressed in spring flowering. And in 2012, we had 24 species in flower before April 30th. And this year, we've actually found 31 species in flower before April 30th. And that includes flowering in February. And for Antigonish County, we now have flowering in every month of the year. So the change in the marine environment is going to be looking at change in distribution, both geographically and ecologically, of Fucus serratus. So next. So this is a figure of temperature change across the province for 13 major sites, starting in 1961. And the initial aim of this study was to compare the first 30 years as sort of climate normals, and then the second 30 years as sort of what sort of change has occurred in the system. And you can see across those individual sites, there's been a great deal of change over that time period. And also there's a great deal of variation among those sites in any given year. And this is a bit noisy in which to make any sort of generalization. So we can reduce that down to the next slide. Okay. And so here we have the mean of those values for each year. And the R squared value for that is highly significant. And sort of looking at that, it's approximately looks at 0.25 changes or degrees change per decade, which is a reasonable value. But when we look at that figure in more detail, there's two things happening here. And the first thing is that between 1961 and 1997, there is no change whatsoever. That's an insignificant slope. And similarly, between 1998 and the present day, that is also insignificant. So it seems that it's more complex than a gradual change. It seems to be a step change. And this is illustrated in the next figure, the next slide. Okay. And so here we've plotted these data as sort of a rolling 5-year average. So the first point is 61 to 65, and the second point is 62 to 66, and so on. And what you see here is that up until the 90s, there's no change. So we have a very stable temperature for essentially 37 years. And then post 1998, there's a leap in the temperature. And again, it's remained stable for that period. And I think this is quite a different perspective on what's happening to climate change in Nova Scotia. So what I'm going to do is, in part of this talk, is try and come to grips with what happened in that sort of 97 to 99 period that reflects that step change that we see in annual temperature values. So next. And so this map looks at across the province, and what I've indicated in parentheses here is essentially the step change that's occurred at each of these sites post 1998 relative to the 1960 to 1997 period. And what you see is a very dramatic difference in all of these sites. And if there's one sort of generalization we can make, it's that the points along the Atlantic shore have changed the most. The points of the sort of northern interior of the province have changed the least. And an interesting point here is that when we look down at Yarmouth, it hasn't changed. The change there is not very much, but Yarmouth area has gone from being essentially one of the warmest places in the province in the 1960s through 90s, and that increase has been very limited, and now it's among the coolest places in the province, certainly on the mainland. Next slide. And so if we summarize those changes and sort of throw in all of the partial data that's available on the Environment Canada websites, and we look at a number of sites and look at these things regionally, what we see is that different areas of the mainland of Nova Scotia have changed quite differently. And we've gone from a situation where in the early period, essentially virtually the whole province was below 77 degrees centigrade. And now we're at a time when virtually the whole province is above 7 degrees. And sort of that post-98 increase varies quite considerably depending upon where you are. And the least change appears to have been in Fundy and the approaches to Fundy. So next slide, please. And we'll skip this one and go to the next. So the question is, what is the basis for that step change? And since Nova Scotia is surrounded in water, that change is almost certainly associated with changes in the ocean. And globally, one of the most important factors in weather and climate is ENSO. And this is a plot from NOAA looking at essentially the severity of El Nino events, which are in red on the upper part of that graph, and the La Nina events that are on the lower side of this graph. And what's intriguing here is that we have this in 1998, at the end of the 90s, we have this extremely severe La Nina event. And this seems to be what's correlated with that step change in in temperature in Nova Scotia. The period that preceded it, this El Nino phase, was a couple of cold years. This El Nino phase here was associated with a very cold 2015. And these areas were particularly warm periods in the post-98 period. And at present, we're in quite a severe La Nina period as well. And that's also quite a warm period. Next. So the other oceanographic influence that is almost, that is probably affecting us is this phenomenon called Atlantic multidecadal oscillation. And I'm not sure anyone really understands this. There are papers over the last 10, 15 years which say that this is the most significant sort of atmospheric ocean regulator on the planet. Some people have suggested that this is what's regulating ENSO, and other people have said that this is an artifact. So the key point here is that right now, if we look at global sea surface temperatures, we are in a period of very high sea surface temperatures. And this correlates with a very positive phase of the Atlantic multidecadal oscillation. And so we have in Nova Scotia a period where since the 90s, we have been in this very warm period of this AMO that doesn't show any signs of decreasing. And this may be one of the reasons why the Atlantic coast of Nova Scotia is at least so warm. The next. Okay. And closer to home, I have looked at sea surface temperatures for Halifax Harbor, which have a long-term temperature record dating back to the 1920s. And from the 1920s to 1997, there's virtually no change. The means there in a couple of periods are 7.2, 7.3 degrees. And it's only post-1998 when we see this jump to 7.7. And what's intriguing here is that these temperatures, these annual mean temperatures of the ocean, are higher than they are for Nova Scotia as a whole. And so for me, there's no question that the climate in Nova Scotia has been moderated by what's happening out there in the ocean. Next. Okay. So to move from sort of long-term climate to short-term measures of temperature, and this is the last 6 months. And last year was one of the warmest years in the last 22. And the last 6 months have been almost the warmest ever in Nova Scotia. And certainly the temperature for April has set record as sort of the highest mean temperature for that month. And what I've shown here is the increase relative to the means for that post-1998 period. And you can see that these 13 sites across Nova Scotia, they've all of them have these very strong increases. And that increase is also shown for Kedri, for example. Okay, next. So we can summarize these data in terms of temperature change. We've seen at least a 1 degree temperature change in Nova Scotia over the last 60 years. And most of that change has occurred post-1998 in a single jump. We can also see that there are regional changes across the province, with the biggest changes occurring on the Atlantic coast of the province. And the other sort of local place where we have significant change is Briar Island, and Nick is going to follow on talking about that. And to go along with these temperature changes, we've seen strong evidence for changing flowering phenology. So the plants seem to be adapting to these warmer temperatures, both in the spring and in the fall. Next. So I just want to spend a couple of minutes talking about Fucus serratus. This is an invasive plant from Europe. Next slide, please. It arrived in Nova Scotia in the mid 1800s, and it used to be more or less limited to the southern Gulf of St. Lawrence, with two essentially orphan populations, one in Yarmouth and the other in Blue Rocks, which was known since the 1990s. And when we look at the ocean environment, we've got major changes here in terms of the temperature increase. And we know that that part of the ocean is a major hotspot for ocean warming. So we've seen, to go along with that, major reductions in winter ice. We've already seen documented the disappearance of major kelp beds in St. Margaret's Bay and adjoining areas, and major reductions in sea urchins in the shallow subtidal zone off the Atlantic coast. And both of those sort of, both the seaweed and the urchins have this threshold of around 20 degrees when they're no longer viable. Next. So, and this is relevant both to the ecology of the South Shore, where this past year we found major populations of Fucus serratus moving up into the intertidal for the first time. And that's important both ecologically, because that part of the shore has historically been dominated by one economically important species, Irish moss, and the mid-intertidal by another economically important species, Ascophyllum nodosum. Next. So this shows what was previously known about the distribution of the province, and interesting molecular studies have shown exactly where in Ireland and in Scotland those populations originated in the southern Gulf. Next. And so this is our sort of recent mapping of Fucus serratus on the South Shore. The original population up near Lunenburg was at Blue Rocks, and we've seen this major spread down the coast, so that it's essentially at any of those outlying headlands, one might expect to find this species now. Next slide.
David, just a note that we're at the 2-minute warning for your time.
Okay. And so this is the zonation that we did at Kingsburg. And what we see in the gold at the right hand is the fact that Fucus serratus has essentially taken over the low and middle part of the intertidal zone. It's now occupying roughly 40% of the intertidal zone at that site. It seems to be competing with Ascophyllum at the top, and it's eliminating what used to be 100% cover of Irish moss. Next. And this is harvesting of Ascophyllum. Next slide. So this is, I think, my final slide. But what my concern is here is we've had climate change along this coast. Fucus serratus is a species that's adapted to warmer waters. And in Europe, this species forms a zone at the lower intertidal that is quite distinct. And as a result of warming of the ocean along the Atlantic coast, we're now seeing that same phenomenon in this part of the world. And so Fucus serratus may be taking over much of the shore that was previously occupied by Irish moss and ascophyllum. So I think next slide, that might be my last one. So this is a summary slide. We see major competition between the Fucus serratus, this invasive species, and our native ones. And it's now becoming a dominant species that everyone should be looking out for on the south shore of Nova Scotia. So I'll stop there. Thank you.
Thank you, David. And we're going to transition now to a presentation that you will share with Dr. Nick Hill, and it's entitled The Missing Years, How the Inadequacy of the Weather Record Masks Climate Change of Conservation Concern for Endangered Plants in Nova Scotia. And Steve, maybe I'll encourage you to monitor the chat, and David as well, for questions that could be answered in the chat. And thanks to Nicole for sharing the screen there, last presentation. Over to you, Nick and David.
Hi, Leif, am I on?
You're on, and you can go to full screen for that if you like it. There you go, and we can hear you loud and clear. Thanks.
Okay, thank you. So thank you, David, for doing a lot of all of the heavy lifting on that, on climate, getting into the possible mechanics. The only heavy lifting I've done recently is lifting bamboo canes, and I'll get to that. This is called The Missing Years, How the Inadequacy of the Weather Record Masked Climate Change of Conservation Concern for Endangered Plants in Nova Scotia. And the reason that I'm saying this is that we have a recovery strategy for the endangered eastern mountain avens, and we have been looking at sort of proximal concerns and threats, and unbeknownst, the climate has been changing. Obviously, we are living in climate change, but I think you'll recognize that the climate change may have been more than we bargained for. These are the climatic regions of Nova Scotia, one version of them, and these are some of the things that are impacted by climate change. Canada jay, the moose, the rock rose, the purple sandpipers, the eastern mountain avens, which I will be talking about, and the Plymouth gentian. And when we look at Briar Island, Eric Mills gave a presentation to the town hall maybe 7 years ago, and in it, he was talking about how the upwelling keeps Briar Island cool. And I think we all took that on, and we thought, okay, we're living in an exceptional place here, which is cooled by the ocean. Many of us, including John Brazier, including all the people who are working on this, Rob Jameson, we've looked into the weather records by times and said, gosh, can we say anything about the climate of Briar Island? And as we looked in the weather records, and remember that we started working on the island for serious about 2014, 2013, and we'd look back to 2006, and you see these two tables on the right, and you see the 2006, the weather record disappears. It reemerges about 1992, so there's a lot of missing years. And it reminded me of a song that I really liked by John Prine called The Missing Years, and that's why I titled this The Missing Years. So, but when we looked at Briar Island and thought, well, are there stations around the mouth of the Bay of Fundy that we can learn from? Yes, there are. There's two, and David talked about both of these, Parsborough and Yarmouth. And when you look at their climate normals, 1961 to 90 and 1991 to 2020, there wasn't a lot of change. There were changes, 0.6 and 0.8 respectively for these two stations, which line the Bay of Fundy. And we could have looked at St. John, but we didn't. There isn't a lot of change that you wouldn't think is normal climate change. And yet, if we look at the bay, we know that the right whale has moved out of the bay and that its prey, Calanus thinmartius, is a cold adapted species and it's been going down. There's a lot of research on that. And here's a recent publication from 2015, Pershing et al., which is suggesting that the surface temperature warming rates may be as high as 0.23 centigrade per year in certain abnormal years. So the water is changing, the seawater is changing. Now, if we take those missing years away, and these are the missing years here and here, and we only look at the temperature of Briar Island and we string that together, you see what David's talking about, that there seems to be very little change. And then we step up in the 2006, because this is all that's available, to 2020, and there's a step up change. I don't know if this is allowed to put a line through a step up change like this, but I have. And similar to David, we get an R squared of 55%, and it's an upward average temperature change for Briar Island. If we do some corrections for the data that we have, because we can't just take the years that we have to see if we take all of those 11 weather stations, what that would do. So I did that, and yes, the climate goes up in Briar Island to the climate normal number 2, which I'm waving my little wand around on. That goes to 8.2. But if we correct that for saying, well, what would happen if we did the same thing with other weather stations, we damp that down a little bit, and we have basically a 1.56 degree increase for Briar Island. Interestingly, Western Head is the only other place that has increased that much, and that's on the other side of Yarmouth. So it may also be this sea phenomenon, this sea temperature increase. Then if we look at Briar Island and look at the temperature in 60 to 90 versus the second climate normal, we'll see this dotted line, this hump that I'm going up, and then the lower line, which was the previous climate normal. Something's changed, something really dramatic. And let's look at Jimmy's Pond, which we restored. East Coast Aquatics, Mike Parker in person restored this pond. It was an ice pond for keeping halibut cold during the springtime and summer from the ice. This pond was constructed for that purpose. It's at the outflow of Big Meadow Bog, which we have restored for the eastern mountain avens. But this pond was constructed as an ice pond. But now look at that, there's only 2 months where the temperature dips down at all below zero. In the old days, in 1960 to 1990, it used to dip down January, February, and December. Now it's only a little bit of January and February. This is a little rime of ice on Jimmy's Pond. But interestingly, Mike Parker excavated a hockey puck out of that, which I've handed over to the owner of the pond, Danny Kenny. The Eastern Mountain Avens is an emblem. It's a rare and endangered species, but one of the reasons that we're interested is this is a whole community of boreal disjuncts and cold weather species. And the bog that we've restored for the Eastern Mountain Avens, it was known for its production of Jonesberry, which the rest of the world calls cloudberry or bake apple, but it had its own name on Briar Island. So it was a species of real note. And now the Jonesberry has gone down on the island. And it's not just because of what's happening in Big Meadow Bog, which I'll talk to you about. It's also climate that we dropped the ball on. We have been measuring CO2 evolution, and this is something we want to get back into. But this is the whole panoply of species. There's a liverwort, which is a rare, really good water quality indicator, and Dolometes striatus. But there's also a dwarf birch, Carex livida. What are the climate change processes that can increase that we probably should have been thinking about more? We've been battling this bog, trying to put it back to rights. It was ditched in 1958. But what are the processes that climate change has exacerbated that were really kind of the other thing that we should have been thinking about? The increased peat decomposition over winter. It's well known that decomposition happens over winter, even when the temperature is like 2 degrees centigrade. What does that mean? That means that there's more nutrient mineralization, and there's more nutrient mineralization in the late fall, which means that species won't be shutting down for winter properly. There's also more nutrient mineralization in the early spring, and we've got to understand that this is going to cause shifts in the plant growth. Evergreen shrubs may be more favored, and people studying the Arctic tundra have talked about this lovely word, shrubification. There will be drying out of some areas, but our whole restoration strategy for Big Meadow Bog was to stop that drying out. And East Coast Aquatics put in 150 ditch blocks to prevent the drying out. There should also be more fires, one would think. Here's the climate shift. These are the evergreen shrubs that can endanger the avens. Avens now is leafing out in April. Here's another thing for climate change. Researchers have to get out earlier. In Kentucky, my field season went into December. Maybe in Nova Scotia, we're going to have a full field season. We can't just start with the students in May. We got to start ourselves in March. So now there's only 2 months below zero. Are the evergreens going to photosynthesize all winter and make a shift and outcompete the eastern mountain avens? So I've highlighted the two areas, January and February. February is an incredibly temperature warming month at 2.7 degrees centigrade. And on Briar Island, December gets up almost a +3 degrees centigrade increase. Shrubification has been followed in the Arctic, but it isn't just all shrubs. Some shrubs do badly, some shrubs do well, and that's what we're finding here. We need to get onto this because we've got some shrubs like Myrica Gale, which when it's wet and when it's warm, even though it's wet, these shrubs are very adapted to wetland conditions. So we got to keep an eye out for our facultative wetland and our obligate wetland shrubs. These are the ones that may start overrunning the species that the biodiversity of concern, like the eastern mountain avens. As I noted, this is the principal habitat for the eastern mountain avens in Canada, Big Meadow Bog. There's been a big federal and provincial program to rehabilitate this system. Brad Toms of MTRI has done this work that I'm looking at here. The red is the open areas around the bog, which are habitat to the eastern mountain avens. And we can see from 55 before the ditching to after the ditching that this whole region grew up with tall shrubs and trees. Now, we thought it was the ditching. How much was the ditching and how much was climate change? And how much can we actually affect if climate change is one of the pushers, one of the drivers? It's not just ditching. This is the ditching. This is Wally DeVries, Andy Sharp of Kedgie, and Mike Parker. This was East Coast Aquatics. This is the kind of way that they fixed these ditches, by putting in these ditch blocks. And locally, we can see that it's very quick response time of the opportunistic flora. So for shrubification, if we let it go, no adaptation, no adaptive management, we're going to get shrubs and tall trees. Some of the mitigations we can do is try and expand the population of eastern mountain avens and keep gulls out, because climate change is going to mean more nutrients, but gulls also mean more nutrients. And we've got a gull problem on the island, which may have been kicked off by the ditching and the gulls coming into the ditches and using these as lookouts. We may be losing the ideal of what I used to call beauty bog, and now I'm afraid we're calling this bamboo bog, as you shall find out. So in a recovery, in a restoration, we had the hydrological restoration. We've recovered the water table of this marginal zone of the bog called the lag, check. But we're finding that tall shrubs are persisting. So what's the mechanism here? Well, it could be that various shrubs are selected and that these are doing well, and we need to look at our permanent plot data, look at the radial growth of the different shrubs. Action, well, nothing. We're not going to do anything. This is a natural process. Ammonium mineralization from flooded peats. We might have thought that if we flooded peats that had been dried out for a while, that we might get ammonium and that this might increase shrub growth. We can look at lab mesocosms and field manipulations. Again, action, I'd suggest nothing, because this is a transient process. The inflow of phosphate, however, and from the gull bog and nesting, we are tracking phosphate, and we need to do more of this. We need to determine the flux and the fate of phosphate. Where does phosphate from the gulls go? There are 2,000 nesting pairs in this one habitat, which is the habitat for the endangered eastern mountain avens. We got to monitor this. And the gulls, action, yes. And Julie McKnight notified us about planting bamboos. And these are the gulls which are invading Big Mano Bog, and they used to go into the mink farms of Weymouth, and they bring back all that nutrient to Briar Island. Kate Schlepper is an advocate for gulls, but she also studied these movements of the gulls and found out where they were moving, as did Ron Coney and others, Mark Mallory and Jocelyn Kickbush and Nelson O'Driscoll and many others. We were looking at how this phosphorus doesn't just change the vegetation, but it can also change the movement of mercury throughout the bog.
Nick, we're just at about 2 minutes left.
Okay, this is bambooification, Leaf. And one of the ways for stopping these gulls, which are increasing shrub growth, is to plant bamboos, and gulls don't like to get into bamboos because they can't fly in and out. The next thing we're trying to do to beat the shrubs is to give the avens new places and expand the population throughout the newly restored lag zone. The flooding may be too intense for the eastern mountain avens, and I'd suggest that this would be a great laboratory study for Acadia University to look at how the eastern mountain avens grows with rapid increases in water levels. One of the things that we're fighting is the evolutionary strategy of the plant itself. We tried to take shrubs away, but found that when we did, the quantum yield, or the photosynthetic response of the plant, dipped down immediately from control to clipped shrubs. In one day, we got a 12% reduction in photosynthesis. So for something that is adapted to cold regions and tries to stay away from the sun, sometimes just a mechanical approach doesn't work. Let me skip some slides. I'm just realizing that we are getting close to time. And let's skip down. Fire. Fire is one of the things which will increase with climate change. throughout this area that I'm suggesting that we enhance the population of eastern mountain avens, we're finding charcoal from 15 to 55 centimeters in depth. From what we know of the timing and the growth of peat, the peat layers, 10 centimeters equals 170 years. So these are old charcoal deposits, and we have to think that we need to reestablish the natural disturbance regime, because these episodic fires are setting up new genetic individuals. And this is work that Chris Cozella and Mark Johnston have done at Dalhousie University. And this is something from, as James talked about, the review of natural disturbances. Well, I'd suggest that we do the same thing on Briar Island. I'm just flipping through here. And we've got a projected temperature increase. And should we say it's now too hot in the hot tub for eastern mountain avens? When do we say it's too hot in the hot tub? When do we say we should start to make test patches of of the eastern mountain avens? We should make test patches in places where the nutrient concentrations from the underlying geology are the same as Briar Island or close. The shrubby cinquefoil, Daisy-phora in Point Michaud, shows us that this metamorphosed basalt peatland could harbor the eastern mountain avens. Cape Breton Highlands is another area where I'd say we should be expanding populations in a test manner, because at some point we're going to find that the island is too hot. Should we make test patches in Corner Brook? And I'll leave you with that.
Thank you, Nick, and thank you, David, and fascinating, and really you're starting to touch on assisted migration here, and really considered adaptive management to the next level. So thank you so much. Sorry to rush the delivery there near the end.
Understand.
I'm going to ask if I could ask you to monitor the chat for questions. I'm certainly getting some kudos in the chat there now, both Nick and David. So thank you so much.